All right, guys. So as we were saying now, if we find multiples of 4 and multiples of 6, and just to put back these multiples of 4 and 6. So we have multiples of 4. So we have, if you're finding multiples of 4, you're actually counting by 4. So we have 4, 8, 4, 8, 12. And then we have 16, 20. We have 24. And if we have multiples of 6, we have 6, 12, 18, 24, 30. All right, so these are multiples of 4 and these are multiples of 6. And we want to find the lowest common multiple, right? Now, if we look in terms of the multiples that are common, we see that 12 is common in the multiples of 6 and 4. And we also saw where 24 is common in the multiples of 6 and 4. But the one which is lowest would be the 12. So our LCM is 12. Now, why do we want the LCM when we're adding fractions that don't have the same denominators? Why do we take the LCM? As Ms. Wilson said, we're trying to find the lowest equivalent fractions that 6 and 4 can go into. So the lowest common multiple gives you the lowest number that 6 and 4 can go into to make equivalent fractions. That's what we are doing. So if we are making equivalent fractions of 5 over 6 and 3 over 4, everybody is following? Then now we have to express the fraction with the same denominator of 12. And if we do that, what would be the numerator for the first fraction here? And what would be the numerator for the second one? Anybody?
Sure, repeat again, if we do what?
We are expressing these two fractions in equivalent fractions of 12 as the denominator. So in other words, instead of having fraction that cut up into 6 parts and 4 parts, we want fractions that are cut up into 12 parts. So we are saying that we know that the fraction that has 6 parts and the fraction that have 4 parts can come out of 12 parts.
Yes, sir.
So all we want to know now, what would be the numerator for this first fraction over 12? What would we put up here to be
10, sir.
equivalent to this?
10.
All right. How would we get the numerator to be 10?
Sir, we say that 6 into 12 is 2, and then 2 times the numerator.
All right, so Ms. Raysom said 6 into 12 is 2. So we'd say 2 times the numerator. All right, fair enough. So what we're really doing then to get equivalent fraction, when we find the LCM, to get the first equivalent fraction, which is 5/6, we want the equivalent fraction for 5/6. We want that fraction now with a denominator of 12. So to get that, Ms. Raysom says 6 into 12 goes on 2 times, and then we take that 2 times the 5 up here and multiply, and we get 10. Everybody agree with that? Raise your hand if you agree with what Ms. Raysom has said. All right, Mr. Good. Anybody else? Right, so rightly so, that is correct. Now, but if you think of it in another way, to get this 12, what you would have to do with the 6? You would have to times it by 2. The same number that you use to times the 6 by to get 12, you use the same number times the numerator. So you would have 2 times 5. You get what? 10. All right, so it means that this fraction here would be just simply 10/12. And it would be equivalent to 5/6. Now, how can we get the numerator for the next one then? What would be the numerator for the second fraction? What would you do to this 4 to get 12?
Times it by 3.
You would times this by 3. So to get the numerator, you also have to times it by 3. So we say 3 3's give you 9. Everybody see that? Now, instead of subtracting 3/4 from 5/6, we instead subtract in terms of their equivalent, because 10/12 is the same as 5/6. 3/4 is the same as 9/12. But because of the rule, we cannot subtract fractions when their denominators are different. That means you have to write them in an equivalent form where the denominators are the same. So when we write them as the denominator with 12, the equivalent to this would be 10/12, and the equivalent to this would be 9/12. Now that they have the same denominator, now we can subtract them. And so we would say what? 9 from 10 give you what? 9 from 10, students? 9 from 10, you get what?
1, sir.
So you have 1/12 remaining, right? So when we are subtracting fractions, or when we are adding fractions, we have to make the denominators the same. So if the denominators are not different, we find the LCM, and the LCM, we use that to make equivalent fractions that we can subtract. So the denominator now would be the LCM that rather than what we had before. So that's what you're really doing when you're adding and subtracting fractions where the denominators are different. All right. Now, this is not the way that you would generally work it out, because we don't generally write out the fraction like these and make equivalent fraction. But what you're more used to is you would just simply draw a bar and put the LCM down here. And then what you would say now, you take each of these denominator into the LCM and then times the numerator. So you say 6 into 12 goes 2 times. Then you take the 2 now, times the 5, and you get what? 10. And now you say 4 into 12 goes 4 into 12?
3, sir.
3 times, so you take that 3 and times the numerator. Well, this sign here. So 3 is 9. So now we can just simply subtract 9 from 10, and now we get 1 over 12. All right, guys, is everybody clear on what is happening here? Raise your hand if you understand clearly what is happening.
Sir, can I get one more example, sir?
Yeah, we can do another example. All right. Now, so let me clear these. Now, suppose we have 2 over 8 plus 3 over 24. Are the denominators the same? Are the denominators the same, students?
No, sir.
So if the denominators are not the same, then we should find what?
LCM.
Right, the LCM. And sometimes we may say LCD, which is the lowest common denominator. So the LCM of 8 and 24 would be what?
24.
24. So we would have 24 as the LCM. Now we would say 8 into 24 goes how many times? Remember that we are dividing the denominator into the LCM so that we can find out what to multiply the numerator by. So 8 into 24 goes what?
3.
3 times, sir.
So it means that in order to make this in an equivalent form, we have to multiply the numerator by 3. So we have 3 times 2 give you what? Everybody see that? Guys, are you following me? Raise your hand if you understand what I just did.
6, sir.
Okay, good. Now we want to say now how many times 24 can come out of itself. So that will give you 1 time. So we have 1 times the numerator 3. So 1 times 3 give you 3. And so now we just simply add the numerators. Now, remember now, they both now have 24 as a common denominator. So once the denominators are the same, we can just add the numerator. So this will give you 9 over 24 Now, generally, when we write in our answer, we always try to express our answer in the lowest form, right? So what's the lowest term for 9/24? What would be the lowest form? Can we cancel 9/24?
Yes, sir. 3/8.
And so we use 3 to cancel. So we say 3 into 9 goes one time, and 3 into 24 goes.
3 into 9 goes 3 times, sir.
Sorry, 3 into 9 goes 3 times, and 3 into 24 goes what?
8 times.
8 times. And so it will become, fraction will become what? 3/8. And that would be the lowest term of the fraction. All right, so we generally try to express our fraction in its lowest term when we're given the answer. Is that clear, guys? Any question? Is everybody clear on how to add fractions that have different denominators? Raise your hand if you're clear. Okay. All right, so that would have given us rule 3. So rule 3 says that if the denominators are different, we express the fraction with the LCM or LCD as a common denominator. And so we would get this as an example, and then that would simplify to 1/12. Now, looking now at rule 4. Rule 4, for mixed numbers, we have 2 different approaches when we are dealing with mixed numbers. If we are adding mixed numbers or mixed fractions, one rule is that we can convert the mixed number to improper fraction, then we add in the usual way. So let us look at this example. So here we have, so let me just write this down. So we have 1.5 plus 2 2/5. All right, so basically, these are what we are working with, all right? Now, if we are following this rule, it says that you have to convert the mixed number into improper fractions and then add in the usual way. So if we convert these into improper fraction, what would we get for the first one? So 1.5, what would we get as an improper fraction for that?
3/2.
All right, so we will get that by multiplying whole number by the denominator, add the numerator, and then put it back. So 2 ones, 2 plus 1, 3, put it back over 2. So this becomes 3/2. Everybody see that so far?
Yes, sir.
All
I
right.
don't know the 12/5.
And for the other one, it would be 5 times 2, 10 plus 2, 12/5. Everybody see that? So that's
So you times the denominator by the whole number, then add the numerator, sir.
right. Exactly. That's what we're doing. That's when we're doing the conversion. That's what we do. Is everybody clear on that? Raise your hand if you understand how to convert mixed number to improper. All right, good. All right, so once we do the conversion, and now we have improper fraction, then we will add in the usual way, meaning the rules that apply in rule 3, we can apply it now. Because what we notice here is that the denominators are different, and so we need to find what? We need to find what's the
LCM.
LCM. So what is the LCM for 2 and 5?
10.
10. And so what step we do next now after we find the LCM?
Divide the 2 into the 10 and then add the 3.
All right, so 2 into 10 gives you what?
5.
5.
2 into 10 goes 5 times. And what we do with the 5? We put down the 5?
No, sir, you add it to the numerator. Just true.
You add it to the numerator? Buddy?
Yes, sir.
Multiply it, sir.
So we're to multiply the numerator, not add. So we said 2 into 10 goes what? 5 times. Now we say 5 times the numerator. Give you what? 5 times 3 is?
15.
15.
Work with me, work with me. And then now we say 5 into 10 goes how many times?
2 times.
2 times. And now we say 2 times what?
12.
2 times 12.
12 give you 24.
24.
And now what we do next?
Add the 15 and the 24.
And we get what?
39.
39 over
10.
All right, now our answers in maths, we don't like to leave our answers as improper fraction. So we generally mix our improper fractions. So convert our improper to a mixed number. What would we get here?
Three and 9 over 10.
3 and 9 over 10. Anybody else get that answer?
Yes, sir.
All right, good. So that's 3 and 9 over 10. So that's what the answer will work out to be when you mix that improper fraction. Is this clear how to add mixed number using this method? All right, let me see if I can give you one to try. So we have 3 and 3/4 plus 2 and 7 over 12. All right, guys, write this one and tell me what you get for your answer. Raise your hand when you're finished so that you can get your answer. All right, so I see where Miss Waysome and Trivia would have finished the question. Anybody else? All right, so Trivia, can you walk me through the question?
Okay, sir.
All right, go ahead. Tell me what to do.
Okay, first we're going to 3 fours 12, and then we add
First we are going to 3 4 12.
multiply the whole number by the denominator. So we say 3 fours 12
So first we are going to convert our mixed number into improper fraction.
four.
We start by converting the first.
Okay.
We get what? Do the conversion, miss. 3 4
3, the whole 12
3 4 is 12. What next?
plus 3
So we should get what here?
$15.
That's 15.
Yes. 15 over 4
15 over 4. What next?
Next we'll 2 12s 24 plus 7 31 31 over 12.
All right, 31 over 12. And what next?
Then we're going to find the lowest common multiple.
All right, so what is that now?
12.
What next?
All right, then we're going to divide the 4 into the 12.
All right, 4 into
Goes 3 times, and 3 times 15.
All right.
45.
Give you 45. I hope everybody is following so far. And next, what we do?
All right, you put back the addition sign. Then 12 into 12 go 1 times, and 1 times 31 equal 31.
All right, so we get 31 here. So
equal to 76 over 12.
what next?
Then I divided 12 into 76 goes 6 times, with a remainder of 4. So I put back the 6 and 4 over 12.
Can we simplify that any further?
Yes, sir. 6 and 1 over 3.
All right, so that was the answer. Let me see the answer, those who got that answer. This way some. Miss Scott, did you get that answer? Did you get that answer, Miss Scott? Are you hearing me, Miss Scott? Miss Green, did you get that answer?
Yes.
All right. All right, Mr. Campbell, you got that answer, right?
Yes, sir.
Mr. Adriano, I kind of realize that your
Yes, sir. Yes, sir. Internet kind of
yeah,
fluctuate.
in and out. I realize that. Were you able to work this question?
Yes, I'm working long time.
All right, and you got that answer. All right, good.
Yes, sir.
Xavier, thanks much for that. All right, so everybody should be able to add mixed numbers or subtract them. All right. So let us move on. You can lower your hand now, Miss Xavier. So the rule says that, 1 second, guys. Sorry about that, guys. All right, so we would convert our mixed number to improper, then we would add in the usual way. Now that's one way how we can add mixed numbers. Now another way to add mixed numbers, we can look at this as rule 5. So we could add the whole number parts and add the fractional parts separately. All right, so if we're doing the same question, the one that we did in the first example. So we have 1.5, and we are adding it to 2 2/5. Now, instead of converting it to converting it to improper fractions, we could just simply work with the whole number part separately and then work with the fractional part separately. So what that really means, we are going to take the whole number parts and group them. So the whole number part for the first one would be what?
1, sir.
1. And the whole number part for the second
1, sir.
number would be 2. So we have 1 as a whole number, 2 as a whole number. So we just add those in a bracket by themselves. So that would be the whole number parts. Now we have the fractional part, which would be 1/2 and 2/5. We also add those in a brackets by themselves. So 1/2 and 2/5. Now, to add the whole number, that should be pretty straightforward. 1 + 2 would give you 3. Now, the fractional part, you have to do that in the way that you normally know how to add fractions. If the denominators are different, you need to find the LCM. So the LCM of 2 and 5 would be what? Come guys, respond please. 10. So now we would write 10 as the LCM. How would we get now the numerators? So we would say
5, sir.
2 into 10.
2 to 10 goes 5.
5 times 5.
5.
Keep back our plus sign. Then we say 5 into 10 goes
2 times.
and then we multiply 2 times 2, we get 4.
4.
So now we can just add the numerator for that. And so we have the whole number part, which is 3. Plus, if you add the numerator here, 5 plus 4, you get 9 over 10. Now, you have a whole number and a fraction, and you're adding them together. Once a fraction is a proper fraction, you can just put them as a mixed number. So 3 plus 9 over 10, 9 over 10 is a proper fraction. We can just group the whole number 3 with the fractional part 9 over 10. So the answer would be 3 and 9, 10. All right, is that clear to you guys? Raise your hand if you understand what I'm doing. All right, good. So this is now an alternative way. If you don't want to convert your fractions to improper fraction, but instead you want to work with the whole numbers and the fraction separately, this is how you would go about doing that. Any question? Any question, guys? Clear as crystal? Let me see the hands of those who feel like you're okay with this. Ms. Wilson, Ms. Green?
Yes, sir.
All right, I see your hand, Ms. Wilson. That means you're okay. Ms. Green, are you okay with this?
Which grade you end high school?
I wasn't quite hearing you.